working in a project with development mode, working in a project in a kind of feature maintainability mode. Feature maintainability in the sense that kind of enhancement or bug fixing is software is available. Whereas in development, software is not available. Means someone is developing the software from the scratch. So in development mode, a developer need to include many libraries. Where in maintainability code, the developer has the software. So in both cases, a developer needs to know about the either library package or the current software. If we see Python is kind of loosely, or it doesn't have any explicit type, function signature, class attributes, module attributes, wherever you see. The variable they do not have type. Means Python understands and it instantiates the typing implicitly. Programmer can explicitly declare a variable, but not required. Means there are kind of notations through which, like if it is double quote, then it is a string. Otherwise, if it is kind of a decimal number, then it is an integer or it is a float. So problem is, so if I am developing a software or I am kind of maintaining a software, how I should proceed? That is a big task. One work is that I can go ahead and I can just look at the library package if I am developing, or if I am maintaining the current software packages and source code and class code. It's a multi 10,000 lines of code that I need to understand before I start. It takes months. Like any widget programming, if I need to use a widget, then I'll go with the widget class, then search here and there all the derived classes, then think about its kind of usability, means which widget I should use. In Python, adding to a class data structure or adding an attribute to the class instance is runtime. You can add in any methods, in any function. You can kind of grow your class data structure, class instance data structure. Reading code is kind of cumbersome. So what is the solution? Solution is that I should know the design of the library package or design of the current package in advance. If I have the design package, means kind of package diagram or class diagram, interclass diagram, interpackage diagram. So these are called kind of UML schematic diagram or kind of architectural diagram. So rather than going inside the code and picking here and there, it's very nice that if I start my work, rather than investing weeks or months in understanding code here and there, we can have a kind of architecture in the hand. I can take printout of the architecture. I can just browse on my mobile. So if I need a particular class to be used, just I can browse the class diagram, interclass diagram. Inside the class, if I narrow down in few classes, I can just browse through the attributes and its methods, and I can decide, okay, so at this place, this class, I need to instantiate. So class diagram, package diagram, I need to have in my hand. So how I can proceed? I am writing a code, library package or the current software architecture, how I can do it? I have Python source code. Python source code is not a big deal. Means if I install a software in Python, Python source codes are available. I mean, they only execute. Or if software includes a shared library, then Python code means for famous library, anyway it is available on GIT Hub, code repository or something. So getting a source code in Python is not a kind of a big issue. So if I have a Python source code, a solution is there any tool or software that would kind of parse the Python code and give me the architecture? I did not go all the places and see that if someone is attached to self or someone is attached to the class data structure or something like that. It's not C++, where the initialization generally happens in the constructor or something. Anywhere kind of attribute initialization or attribute addition can happen. So if I get to have the architecture of the class of the library package or the current package, it is a kind of a boom. Means you can start immediately if you have the blueprint of the architecture. So we'll see the PyReverse tool that parses the Python code and then it generates the kind of the architectural blueprint, package diagram, class diagram, inter-class relationship, everything is there. There are few things that is lacking in PyReverse. Like for in a class diagram, we don't have the derived classes, only the kind of parent classes are there. Kind of, we can have our own software that uses the PyReverse, and whatever is lacking, that you can fill in. Just run the tool in 1 hour, 2 hours, full architecture is there. Just use the architecture kind of in PDF format or something. You can just, when you are free, you can just sit and browse the architecture. Start using it. So we'll see that how in a reverse engineer we can generate the UML architecture, class diagram, package diagram, and interrelationship through PyReverse and any tool that is using the PyReverse. That is. Further to discussion on generating UML diagram through reverse engineering of the Python code. So we'll see Numpy package that is used in machine learning, and Numpy is famous for multi-dimensional array and many C array like character array and record and those kind of things. So matrix and so ready-made computational classes are available. Okay, so we'll proceed. This is Linux Mint. We'll see first the kind of introduction about the tool that we are using, and then we'll install Numpy and then we'll proceed in that way. Okay, so Numpy is so this PyReverse is a reverse engineering tool. It generates class diagram and package diagram. In class diagram, attributes and methods are available, and inter-class relationship. So, and in package and module diagram, inter-package relationship, module is considered as package here. So, inter-package relationship. Okay, so it draws class diagram mainly through modeling element where two classes can be related through generalization like inheritance or interface realization. Containment, aggregation and composition. Okay, aggregation like partly whole life relationship, and this is complete whole life relationship. Means if a composed object will have no existence if composing object dies, dependency, if one is dependent upon other or it calls any other class. Association is a kind of relationship where there is no dependency, like a teacher is associated to many students. PyReverse package can be installed through, it is available in PyLint package, through package manager or through PIP, it can be installed. Okay, and Numpy can be installed like Python 3 Numpy, and or its source code is also available at GitHub. Okay, so we can see the packages. PyReverse tool mainly it shows like class diagram and package diagram. So we can provide kind of a module list or package directory, list of modules to generate the class diagram, package diagram, or a package directory would also work, where everything inside the package would be kind of drawn. And it has capital A, it will show all the ancestors, minus S is all for all associations. My is for module in full format. N is not in full format, only module would be there. Minus K is only a skeleton of the class. Its attributes and method would not be listed. Minus C, if inside the package or module, if we want a class, full class to be displayed, so attribute and method would come. Okay, so minus A is how many level of inheritance we want. Minus is how many level of association. Okay, minus my and minus kc. We need to set Python path if the package is not in the kind of Python path, then we need to add it explicitly. Okay, so then we'll see how it generates. Okay, so it generates in this fashion. Okay, like base is the base package where it contains package 1 and package 1 contains package 2. Package 2 has module and package 1 also has module. Okay, code is written in a way that package 2 is kind of dependent upon module 1 and module 2. Base is also dependent upon module 2. So this is the code. In the base init file is there, and it kind of depend upon package 1, package 1 dot package 2, package 1 dot package 2 dot module 2. So this is what we can see in the package drawing. And here in kind of package 2 init we see it is depend upon module 2 and module 1 both. So in that sense it is both are shown. So this is the way, like package 1 if we see kind of it is depend upon package 2 and module 1. So this is what is depend upon package 2 and module 1. So if this is the code, then this would be the kind of package diagram, whereas this is the module diagram, where there is a module 1 has a class called A, and inside module 1 class B is there, it inherits A, where in package 1 module 1, package 1 package 2 module 2 also derives from package 1 module 1 A. So this is how it generates. Okay, so we'll proceed and we'll install. So the way we have described, we'll install PyLint. Okay, so we'll say sudo apt get install pylint. Okay, it is installed 2.12.2-1 version, and will install okay, so along with that we also need to install GraphViz. GraphViz is also installed. Then we'll install Python 3 NumPy. It is also installed. So if I say dpkg -l e grep -e and kind of pylint or numpy or GraphViz. Okay, so these are the versions that we are using. GraphViz is 2.42.2-6, whereas pylint is 2.12.2-1, whereas Python 3 NumPy is 1:1.21.5. Okay, so 11.2. So this is the version for the NumPy. Okay, so we are ready now, and we'll see where the NumPy is installed. Next is we need to set the path. So first we'll see where it is installed. So dpkg -l python 3. Okay, so it is installed in dist package. So now there is a package called numpy, and this is the package directory. So this package directory must be in the path. So what I can do now is I can just write a code like python 3 -c import sys, then print sys dot path, and it's available. User lib python 3 dist packages. So it's done. We don't need to do anything. So we'll go to temp and we'll create a directory called PyReverse NumPy. This is the empty directory. Now, whatever we have described, like we'll try package diagram from top to bottom. First higher level package diagram, and then lower level package diagram, module diagram, followed by class diagram. So these things we'll see. So we'll generate a kind of package diagram for top level. So I'll say PyReverse -a, all ancestors -s1. If I do capital S for big package, kind of it may not proceed. It is very big, so only one association will say, and my. Okay, so someone has kind of patience, then he can try like this. But we'll do -s1 -my. Okay, and user lib python 3 and dist package and numpy. Okay, we'll ignore test. That's it. Okay, I want it to be printed in PDF format. Now it is going, so we are trying to generate the package diagram of numpy full. So kind of we hope for the best. We'll try for 20-30 seconds. If it passes through, it's very nice. Okay, so kind of it is taking time. Okay, so it took some time, but it completed. So we have now a complete package diagram. So there are two files here, packages.pdf and classes.pdf. Okay, so we can kind of browse through. Okay, so this is Numpy. And we have two files, class PDF and package PDF. So we are interested in package PDF. So this is the package diagram of Numpy. Okay, so this is a kind of a big mesh, but this is the reality. So this is how packages are depend upon each other. Okay, I think no one can understand this very well. And if I click on class.pdf, then this is the class diagram generated. Okay, so this is, I don't think this is also, but good thing about this is every class has methods, and I cannot zoom now. So every class has method and attribute, so those things are also shown. So this big it is. So nice idea is that we can do it for sub packages. So we'll see what all sub packages we have, like user lib, Python 3, dist packages, and Numpy. Okay, it has so many sub packages. I believe I can try core. So I would remove everything. I don't have anything now. So whatever command we used, so same command we'll use now, and we'll say kind of core. Okay, and nothing, no difference. So it would come, it would pass through a little faster. Okay, it is done. Now again there is two classes and packages. So we can see packages first. So this is pretty clear because it is only for a sub package and how they are interrelated to each other. So where we are here. We are here, numpy.core, and it is dependent upon, so the arrow that is coming out of this box is core is dependent upon these packages, array that is coming inside box, those packages are dependent upon this code. So that is the idea, like this is dependent upon sum func and get limits and mem map, memory map, and character array, like this function base. Okay, so how this package diagram are being generated, so it's not that difficult. Okay, so we can just browse vi user lib python 3 dist packages numpy core init, and here we can see the import. Okay, so it from dot, so current directory, it import umath. These lines make actually this tool to work where kind of it import others, like from dot it import numeric, from dot mem map it import everything, dot def character array, dot function, this is what we are seeing here, like dot def array, mem map, and then okay, then numeric, okay, there is a get limits, so there would be get limits, there is a get limit. So if we browse the init file, then we can actually see what are the scenario. So this is how we can generate the package diagram, and we can generate a class diagram. So we will see class diagram. Okay, this is better. Now we can see each classes in the package, how they are interrelated, and each classes attributes. I cannot zoom in after this. So how each classes are interrelated each other, their attribute, methods, everything we can see. Okay. Now if I don't want a full class diagram, only skeleton, then we can just say kind of whatever command we were using, I can say -k, and it would generate kind of a class diagram. So package diagram would be same, but class diagram would be kind of a little different. Okay, so if I do events on, if I see class, so this is only a skeleton. So kind of we'll see later that we have our own tool that is a wrapper around the PyReverse, and it generates a kind of a better diagram. So this is what it is. So we saw the package, we saw the sub package diagram. This is sub package diagram. We can generate for the, so I'll remove everything. So we'll generate for a sub one module also. So this is part we did, -a, -s1, -my. Now there is a module called init. It has many things. It's not a simple module. And ignore test, and okay. So it would draw the skeleton. So I don't want to draw the skeleton. I want everything to be drawn. Now it is parsing the module. Now if I do ls, there is only one file, that is class diagram. Since inside we are module, only class diagram is possible. Now I can browse the class diagram. Okay, there is nothing. Okay, so so it is coming empty. So before we proceed, I think we can see PyReverse help, what PyReverse does and why it is coming empty. So PyReverse, it has F, that is filter mode. We can specify what we want, what we don't want. -C option, the way we said, -A, minus capital A, minus small s, capital S, and -B for built-ins, -M, yes or no, -K, -O output format, colorized, and built-ins, that we'll see what is the depth of the color, how many colors we want at different level. If you want to ignore some file, okay, we can set this as a project name and where the output file would go. Okay, now we'll see user lib python 3 dist package numpy. Why it is not coming? So there are 4 files with init, and we'll see which file is which, how much big it is. Okay, so this is problem with the PyReverse. It cannot work in PYY file, Python interface file, or Python files. Only Python file is required. We doesn't have any class. That's what we saw. So if we try with PYY, like PyReverse -a smy minus, okay, so O user lib python 3 dist package numpy and init pyi minus o pdf. Okay, so even though it is a Python interface file, okay, so nothing is coming again. So no output. So what we can do is we can copy this file here. Being this py file, this is the largest file. So we can copy this here. Okay. So I'll copy it as init.py. Okay. Now we'll try again. So I'll place as colorized. Colorized. We'll try. Okay, so this is far better. Now we can see the classes in a module, and kind of each level of the classes is colored with a different color. So, okay, the cons side of this diagram is every class has a method and attribute listed. So readability is an issue, means if I see a particular class association, then other places are missing. So what we can do, or if we try built-ins, show built-in. Okay, it is even big. I believe it is completely unusable. So with the color only, colorized only, I'll say -k, and only class skeleton would come. Okay, so this is better. And this is only class skeleton, and these are kind of a class hierarchy that we can see. Okay, so either we can have everything about the classes, each classes, or class skeleton that we can see. Okay, so now either we have everything or we have only a skeleton. So that is, so PyReverse, we drew package, and then we did sub package. Now we did a module. So inside a module, we can draw for a particular class also. So colorized -k, I can say -c, and class kind of generic. There is a class called generic, kind of e grep -e. There is a class called generic. Okay. So we'll try for the generic. So I'll say -c generic. Okay, there is another called generic.pdf. So this is the class type. So we did package, sub package, module, and inside a module for a particular class also we can generate. If we want a skeleton, I'll say -k. Okay, so only a skeleton. Okay, so it's a, so this way kind of we can generate class by class, or module by module, package by package, sub package by package, sub package. Okay, so to avoid the limitation of Python code, to avoid the limitation of generating one class each again and again, or to avoid the limitation of kind of only big class, only all class architecture or only a skeleton. So we have written one kind of tool or a software. Okay. So this software kind of first fixes the Python code. Then we can draw the modify. So simple. First fix the Python code and after that start drawing the UML diagram. Same package wise or module wise or whatsoever. So we'll fix the way it is Python 3 fix user lib Python 3 numpy. So this is the package directory and this is the package. So we kind of explicitly mention that this is the package. Okay, nothing else. Simple. Now it is fixed. It created a new directory called numpy and it has the fixed code. So we'll remove this init. We don't need what we had copied. Now this init has py has everything, class generic. So all Python code and everything is fixed, clubbed together in a single py file. Now we can generate kind of a, so we talked about the module. So I'll say Python 3 PyReverse modify numpy, and inside that we want for module init dot py. Inside that we'll say please highlight generic. That's it. So modify numpy init and highlight the generic class. Okay. So it created. So I can say numpy.generic.pdf. Okay. So it has a hybrid architecture. Now everything is a skeleton, whereas whatever we want, it is highlighted, numpy.generic. Now we can see left side attributes, right side methods. In a one go, I can see in a green color what all classes are derived from it. That is bool, numpy, date time, flexible, number, object, and time delta. So that is kind of class of this tool. Internally, it calls a PyReverse. So this is a kind of so no need to go for separate package diagram, class diagram, everything clubbed together. So that is one idea. Now we can draw for the core also, like okay, numpy init. So instead of that, I'll say core. Core is a directory. Okay. So inside core we have file like, so class like u. So full path I'll give u func config dot error dict. I believe this is a class. So whatever we want, so I can say egrep minus e and class in core. Okay. Core numpy core ufunc.py. So these are the classes: error dict optional, support write, whatsoever. So I can try like Python 3 PyReverse minus modify Numpy core, and I'll say u func config, okay, dot errordict. Okay, this class I want in this. So this is a package directory. Inside package directory, we want highlighting this class. We can try. Now it is parsing. If it times out, okay, so it is doing for tests also. Probably we don't want test, otherwise I believe it will be very big. So we'll say, okay, ignore test. So no need to kind of think about timing. If it takes long time, then it would kind of time out and it will try with minus S1 option. Okay, it times out. So it will try with minus S1. Okay, so it finished with minus S1. Now I can see numpy.core. Okay, this is complete one core package class diagram. Now, whatever class we have asked for, that class is highlighted. It is at the corner. So this is class we want. It is highlighted. And for this class, whatever is the kind of method and property that is listed here. So this much only I can zoom. Otherwise, so this class, everything is there, plus a skeleton of the. So this is a kind of the idea we get of the software, that how the software is designed and what it is, so nicely, and for a particular class. Okay, if we want this way, then we can generate for each class a package diagram, or okay, so this is the way we draw the kind of a class in a package, okay, or class in a module. That way, all that also we draw. Okay, so now if we want kind of all class, so this is not only limited for the particular class. So if we want all classes, I mean, kind of I can say all classes inside init.py. Okay, so I'll remove everything. rm.rm PDF. There are 51 files inside that, and it would take time, I believe. Okay, so I think it will take some time. So what we can do is we'll select smaller one. So I would say numpy core. So all classes in core, that makes sense. 30 classes. Probably it is faster. Okay, so it is kind of, first it would list how many classes are available. So these many classes are available. Okay, so these many classes are available in this package. For each class it would draw okay, I think it is done. 21st class it is doing. Okay, if it times out, then it will try again. Okay, so we talked about installing pylint and then installing numpy. We can get from repository also same source code, and then kind of PyReverse help -h we saw, and then all its options, and we see that modeling elements are being drawn. Okay, it is not timing out, but it is taking time, probably class are big. Scenario is better, and I think it would complete. Done. So it has created a many PDF file here that we can see. Many PDF file, many dot file. Okay. Now there is a directory called output, and it clubs everything together, and like we can see here, directory called output, and there is one file called pyreverse.pdf, and everything is here. In one go, everything is here. Okay. Now, if this is a class called casting error, then it has two subclasses also. So for every class, parent classes, base classes, subclasses, everything it draws. That is the classic. Okay. Now, if the green color is subclass, whereas if containment is big, rather than drawing each containment, I believe that would be available still. Class diagram, events class. Okay, I believe we remove this. So, sometimes there are too many containments, and at that time it will be very big. So, only 4 containment, all the containment, if it is bigger, it would place in a yellow box, and kind of it will place the tag here. Okay. It shows the built-ins also, coloring, built-ins, whatever is the best, it shows here. Okay. Again green color, yellow box. For each class, like this ND array contains itself, and sometimes it becomes very big. I mean, in a sense, some 20, 30, 40, and diagram is unnecessary big. It curtails that to only 4 containment. Okay. So this is a kind of, this diagram draws all the class diagram. Each class is complete, all the base class and all the derived classes. So what we can do now is, I can call this Python 3 pyreverse modify and then num complete. That's it. I will say ignore test. Okay. Now all classes in Numpy, it would generate the diagram. So it draws the package diagram, I mean classes inside the package, and it classes. Let's, okay, so there are 333 classes. And I think around 50 classes anyway we have already finished. So I believe it is around 380 classes or something. Okay, so it will take really long time. Okay, so probably 1 hour it will take. So time for tea and coffee. We'll be back. Okay, so it is kind of complete. We have only few classes left. And this is, as described, this is kind of complete package class diagram of NumPy. It's over. Now it is kind of generating the PDF file, and it would club together all the PDF files. So I have two options. Like with the PyReverse, we saw that we generated a package diagram complete. Okay, and I can try that, and we can see the difference. Okay, so it is, I believe it is over. Okay, so it is done. Okay, so this is output PyReverse. This is complete NumPy. Now, the most famous class, kind of the way people use NumPy, is a scalar common, like okay. So like NumPy generic, the way we saw, and it has bool, it has flexible, it has number, it has date time, object, time delta, and then NumPy ND array. Inside the ND array, we can see all the derived classes. So this is the class called array of scalar common. So this is the class where all general use classes are available. Okay. Now we can see all classes like date time scalar. It is derived from protocol, and then typing protocol from typing generic. Okay, I can search for generic class. Okay, so this is NumPy generic class, and this class has these many attributes: base, dt type, and like shape, size, strides. These are the methods. If method, full method, not only method, full method kind of parameters, function parameters are also available, like array and then get field. If it is too big, then it is continuing in the next line. And okay. So okay, it can be seen. We can search for, I believe, another fellow guy called matrix. Okay, so matrix is a kind of a standalone class, like we have macar. Okay, there are many distutil files and many core files. Everything is here. ND array. If I want to know about ND array, it derives from scalar common and typing generic, and behind the scene it has so many derived classes also. Okay, masked array is then inside masked array 3 classes are derived. All descriptions are available. Means this is NumPy. This is NumPy package. I can browse through. This is NumPy bool. Okay, and bool is generic and a scalar common. Okay, doesn't look like anyone derives from the bool. There are bool true dev, bool sub derived from. It's a kind of panoramic. Nothing is required. Complete detail. Yellow is if containment is too big, then it would kind of push in one box like literal, and then it is contained. If diagram is very big, then it makes sense. Built-ins, everything is there. Otherwise, if we drop built-ins, and then it will be kind of too much. So panoramic. Like it is distutil command develop derives in this hierarchy, and one of them contain this and their inheritance. Means just type the command and full detail is available. Okay. See this diagram. Now F compiler. Now GNU compiler derives from F compiler. It has kind of diagram will be very big if we go for boxes for everyone. So 3 containment, it is kind of contained in a yellow box. Okay, and this is derivation. So in a small diagram, full detail is there. Okay, left side attribute and then methods, complete thing is there. Means someone can understand the NumPy image, NumPy package itself, just looking at these diagrams. Okay, config info, amazing. Okay, so kind of we saw the amazing PyReverse and then a tool built upon PyReverse, and it draws kind of so full package. We have view in one PDF file, and we can browse on mobile, we can take printout whatsoever. So nice. I believe this is okay. This is in testing, NumPy doc test, full panorama. So before starting kind of someone writing the code, you can just have this diagram generated and then just started working on the software. Same what we are showing here, same thing we can draw through PyReverse, and it will be very big the way we saw, like user lib python 3 dist numpy. Okay, if someone is drawing minus a minus s1 minus my, ignore test, and then PDF. So this is also kind of complete NumPy class diagram. It generates. We have already showed this, and it will take some time. I believe around 5 minutes it will take. but it won't be that useful, or we have to go class by class. But in the class diagram itself, we saw that there is again limitation. Either it will be kind of complete all classes, methods and attributes it will show, or it will be only a skeleton. That is problem with the class diagram. And this is other problem is that if I in class diagram there is no means it shows the base classes, but the derived classes is missing. So that is the problem. It will take some time. It is kind of generating for full package, so it will take some time. Okay, so it is done, and if I see the complete diagram, classes diagram, then this is this big. Okay, there is no built-in available, and so this is for no use. If I want full package diagram, then this is for no use. I have to go for sub package or module wise. Then for each class we have to draw. If there are 400, 500 classes, impossible that we can draw. So I can kind of magnify it. I don't know how much, so this is the maximum. So this is the problem, or we can draw the skeleton. So class will be in, only name will be there. Certainly this is a kind of the tool we are providing. This has benefit in the sense that everything is there class wise, and against each class we have kind of derived class and everything, those are available, like ND array base class is available, and its derived class in green color also available. Okay, so kind of we have tried that class diagram should be as small as possible. If inheritance is big and containment is big, then we kind of place in green boxes and yellow boxes, so that it will be kind of smaller. So this is kind of complete package. Okay, so PyReverse is a good tool, kind of to generate class diagram and everything it generate for limitations that we are providing, kind of another support. Okay, so like sysinfo, this class, not only inter-class relationship, we provide full derivation list also. These many classes are derived. Contact us for UML training, for designing training, for Python training, for OpenGL training, or machine learning.